Yeah. Okay. So so I think just if you just keep this table in mind, then all the problems related to subnetting will be solved. Okay. So when you want to do a subnetting, okay, you have to decide how many devices you want to have in each of your subnet. So let's say I want to have 1000 devices. Okay. Then you can select 1000. So you cannot select 1000 because it is always in the multiples of binaries of 2. Okay. So 2 to the power 2, 2 to the power 4, 2 to the power 6, right? So you always get it in 2 to the power, okay, because it is binary number, right? 1024. Okay. So 1024 should be, I think, 2 to the power 16. Okay. Uh, 2 power 16 is, no, I think it's not, it is 8, I think then. 10, yeah, it is 2 to the power 10. Okay. So based on that, you can actually decide. Okay. So this is your network address block, what you want to use. And you can see here that since you have used only, you have used only 12 for your host devices. So you have more bits left here. So what happens actually here, you see on 10, okay? So this is like this, 1, 2, 3, and 4, okay? You have used only this portion. You have used 8 here for subnetting and 4 here. So you have 4 bits left here, right? Because you have 4 bits left here, you can create those many number of VPCs now, those many number of network blocks. So that will be like 2 to the power 4 that you can create. So this is like 0, 0, 0, and 0. And the next one you could make 0, 0, 0, 1. And the next one you will get, if you know binary, okay, then it will be like 0, then 1. This will become 2, 0, 0, 1, 0. Okay, like this. And this way you can actually create 32 numbers of 4 and no 16. 2 to the power 4 is 16, right? Yeah, you can create total 16 VPCs. Okay. So when you are building your network, you always start from the subnet part. Okay. That how many devices at then you need in your one network. Okay. One subnet. Okay. And you have public subnet, you have private subnet, right? You put your public front server. I believe that you have learned all of this in the last class, that you put all your public facing servers in the public subnet. All the private facing, like databases, cache layers, middlewares, any other service like batch servers and all, you'll put them in the private subnet. Okay. So this is how you do the networking part. So this is like 2 to the power 4. And okay. So from Tristan, the question is the original address considered a subnet? The start was this and the subnet one is also this. Okay, very good question. So Tristan, what happens is the first one, this becomes your subnet address, but the actual host address will start from here. Okay. So AWS reserves 5 IP addresses in every subnet reserved. So you cannot use 0 and you cannot use 255, something like this. So AWS reserved IP addresses. So if you see AWS reserves this IP addresses, okay, this one. So Tristan, to answer your question, first one is not available. It will not be considered as an address because it will be the network address. First one will be reserved by AWS. Second is also reserved by AWS. Third is also reserved. And last one is also reserved. So what you essentially get is whatever is the number minus 5. Okay. So in this case, for example, you can see that you will not have essentially um, number of devices. Yeah, you will not have 1024. You will have 1024 minus 5. Okay. So is the original address considered a subnet? No, it is not considered subnet. It is considered as the subnet address. Okay. And subnet will start from 1 to 1 less 254. Okay. Because
So in terms of like what you would put in AWS when you're giving the address of the subnets, you would use the 0.1 for the first one, and then the second one would be 0.4.1. So we
okay.
focus on like that first part of the host address.
Okay, I understand your question. No, in that case, there I think, yeah. So I was just coming to it. So there, I think you can use better this tool. Okay, so this is a very good tool which will tell you the subnet address with a marker as well. So here, what you do is you give your network address, you give the mask bit, how many you want to use. So for example, I selected here that I want to have 1000 devices, so I can give 20. Okay, you give 20, and after that, if you do, let me refresh this once. Okay. And I will give it 20. Okay, I will update this, and you can see that if you needed only one subnet, then you will have 4000 devices. But you can divide this, okay, and then you can have two networks. But this will give you 2000 devices in each, but you want more, so you will divide each of this. Okay, but in the AWS, when you are creating your network, you'll first create the VPC. Okay, so you have first, let's say, created the VPC. After that, you will go in subnet and you will click on create subnet. And how many subnets you want? You want 4 subnets. Why do you want 4 subnets? Because you want to have 1000 devices in every subnet. So you can select that and you can copy this subnet address. Okay. Here, and you can select VPC2, and you can give subnet, let's say that CP class VPC2, and let me make the first one as public. So I will make public, let's say 1. Or I can give availability zone. So I can select, say, let's say 1A. So I'll give 1A. Okay. Again, this is like when you select availability zone, every availability zone will give you like a different AZ, different whole data center. So we will select that and we'll give the IP address range here. And you can see you will get 1024 IP addresses. Only you will use 1000 out of that. Okay. In fact, you can use more, but essentially, let's say I consider that I need 1000. So in AWS, you will be using this. Okay. Either you can read from here or you can read from here that I will need to give 22. This one is easier. You can use this one. So let me send these two tools. These two tools help a lot in deciding this. Okay, so this is your subnet address that you give here. Okay, starting. Okay, can someone tell me why do we give when we are creating IP VPC? Why I'm giving? Can I give this 12?
I'm gonna say no because it says between 16 and 28.
Right, right. And what is the reason behind it? So simply AWS doesn't allow it. Okay. Though you could create the network, but at the end, AWS has put the restriction that you can only use between 16 to 28 for this, for your network address. Okay. Can someone tell me why should I put 20? What dictates the decision to give 20 or 22 or 24? How do I make this judgment?
Is that based on this, like you would base that off the number of subnets that you want in your VPC, or is that wrong?
Yeah, yeah, sure, sure. So, so let's say that, I want to have, I know that I'm going to have 1,000 servers, okay? And I need 3 public and 3 private, okay? How do I do it? My question is, I want to build a network, okay? There, I want to have 1,000 devices in every subnet, okay? You understand subnet meaning, right? Subnet is a small section of a network, okay? It's like a public subnet. That means it is facing public, okay? It's a small portion of network which is exposed to public. I want to have 3 public, 3 private subnet. I want to have 1,000 devices in each subnet. How should I build the network?
Would you decide how many number of subnets on the far right so that
Right.
you could figure out how many you need for each of the subnets?
Yeah. Yeah, I think, yeah, you're pretty.
Also, like you have to start with like, so if you have like 1,000 servers and you want 6 subnets, that suffix, like that /20 or whatever, you have to play with that to basically like name the number of bits that you want to allow in the IP address so that you can allocate 6 subnets and then decide the number of hosts. So you'd have to like divvy up which servers are going to go in the private and public subnets after that and stuff like that.
Yeah, true, definitely. But that would come later, right? My requirement, I know that my developers have said that, we need total 6,000 servers. Okay. It's not only servers, there are a lot of things that you deploy. We want to have 6,000 servers, and out of that 6,000 servers, we will have 3,000 in public, 3,000 in private. Build a network for me. Network will start from, let's say, 10.0.0 series we have. So how do we do it? So first thing is, what should be the network address? What should be the subnet address? Tell me how to go ahead with this requirement. Tom, you have half said already. We just need to finish it. Okay, let's proceed. Let's experiment. We need total 3 subnets in public, 3 in private, right? So my approach will be like this, that, okay, I need at the end 1,000 in each, but it gives me only 4, right? I need more. So what I can say that, you know what, not 4, I want 6. But there's no way you can get 6. You can only get 4 or you can get 8, right? Why is that? Because networks get separated based on the binary address. This one. Yeah. So either
So
you get,
because of it being an octal, is that what you're saying?
yeah, because it is in binary. So let's say
Okay.
what would happen here is this is like 0, 0, 0, and 0. This is 4 and another 0, 0, 0, okay, and 0. There are like 8 zeros. Okay. When you are dividing this, okay, let's say you want to have 6. You can have this one, you can have this one, you can have this one, right? The moment you have this one will become 2 to the power, let's say, okay, okay, this will become 2, then this will become another one 2, and this will give you another one 2. This one will give 0 1 0 1, right? This one will give 0 1 0 1, this one will give 0 1 0. So essentially 2 here, 2 here, and 2 here. 2 into 2, 4 into 2, 8. How it will start? It will start like this: 0 0 0, 0 0 1, 0 1 0, 0 1 1, right? Then I think you will have this one. If you add one more on this, this will become, I think, this is 2 and 2 to the power 0 1, 2 to the power 2 and 1 3. This will become 0 0. Then again, if you add, this will become 1 0 1, become 1 1 0, and then finally it will become 1 1 1, right? So total 4 and 4. Total 8 possibilities are there in this. So there is no way that you can have only 6.
Okay.
Okay, I hope this part is clear, how this we are getting either 4 or 8, because when you are doing 4, you only select these 2 bits as your address. So this will become 2 address, this will become 2, 2 into 2, 4. If you want more, you will have 8. But the problem is, the moment I select, I want 6, I cannot have 6, so I will select 8. The moment I select 8, I don't have 1000, I have only 512 hosts left now. But I wanted to have 1000. So what should I do?
Is that where we increase the number of bits? Like, is that where we increase that suffix there to
Exactly.
ensure that it has enough space?
Right. This is where the network address block comes. So depending on what you choose, if you, let's say, end up choosing 4, okay, you will have very less number of devices left, because you have selected this whole part 24, right? 8 8 8. You have selected the whole 8 as your network address. You are left with very few number of devices, right? And if you give more, you'll have less number of networks left. So I was having 20, and here I did not have enough numbers. Okay, so what I can do is, instead of 20, I can, let's say, have 18. If you do this now, you have, see, 2000 devices now. Because what you did, you have taken the address part as complete this, okay? And here you have taken one more bit here. That has doubled the number. If you go give 18, here what happens is, you have gotten 8, then 8, okay, then 2 more. This becomes your network address, and then rest becomes your host address for your host bits. Okay, and since I have gotten 18, I'm good now, right? What I can do, I can easily give 1000, right? I have gotten more number of subnets. In fact, I needed 6, I have gotten 8. I need a 1000 device, I have gotten 2000 devices. Okay. But let's say situation comes another one. Situation is that we had 1000 devices. Okay. We needed 3 subnets. Okay. And sorry. Yeah. And you know, 3 public, 3 private, total 6000. Okay. This will make one network. Okay. This is your network number 1. Okay. My requirement is like this. I want 5 networks. What should I do? I want to have 5 networks like this.
So instead of 3 for public, 3 for private, we want 5 times that. So 15 for public, 15 for private.
Yeah, no. Requirement is not that. I'm happy with this network 1. Network 2, I will decide. I want to have 3 public, 3 private. I want to have 5 public, 5 private. I want to have 1000 or 2000 or 200 devices. That is my decision. I want to have 5 networks in my company right now. I'm not happy with just 1 network. I want to have 5 networks. Once you give me network, I know what to do. I will divide the network myself. I know subnetting. I will do it. So how will the network address go? You see? So this one, you have used 18, right? So what you essentially did, let me make a fresh one, okay? So you had 4, 4, 4, and 4. You have 18, right? So you have taken the 2 bits from here. Okay, 2 bits here, 6 bits here. So this 6 and 8, these are for host address. This is for your network address. 8 and 8, 16 and 2. Okay. So essentially what you are left with, 2 into 2, right? You have two bits here, right? This will be 1, this will be 1. This can be 0 and 1, this can be 0 and 1. Getting the point? But this way you will have only 4 networks.
Yeah, do we have to free up even more bits now to so do we have to decrease that number again so that we can free up those 2 and then allow for variability so that because now we have 4 networks, so if we free up one more set of those bits, then we increase the number of networks we can have to 8.
We can do that.
Want not 18, but 19.
Sorry? Yeah, that we can do, Yams. Yeah, exactly. This is what I wanted to hear from Yams, from everyone. Right? So, see, there are two things we can do. What we could do is that we could borrow 1 bit from here. Leave 7 here. Okay. Borrow 1 more bit here. Okay. Use 1 more bit for this. But AWS doesn't allow this. AWS has said that this play around
16 is the minimum.
16 is the minimum, right? So you are left with no other choice but to look for the bits here. So you'll have to again make this one as 3. Okay. And you'll have to make this one 3 and this one 5. If you do this way, then you have 2 of this, 2 of this, and 1 more 2 here. 2 into 2 into 2. right? This will give you 8. What you wanted? You wanted about 5. You got 8. This solves the problem, right? This solves the problem in this case. Okay. But if, let's say, I increase my expectation, I tell that, you know what? I want to have 5 networks, but I want to have 2000 devices everywhere. Not possible now. This is where you can raise your hands, you can surrender as a network engineer that this is not possible. Because internet has been designed in such a way that it is made of 32 bits. Because the moment you want 20, right, you want to have 2000, right, and 6, right? This is not possible the moment you give it 19. See, it will be reduced to 1000. There's no way you can get 2000. The moment you increase the number of hosts, number of subnets will decrease now. How many of you understood this?
I'll honestly have to go back over it again, but I
Yeah.
think I'm getting the gist.
Okay, cool. I think let's go for a break. Okay. We overshoot. So let's go for 15 minutes break. Okay. Let's go for 15 minutes break. Those who come early, ponder over this again. Okay. Do the maths, take your pen, paper, divide the network yourself. Open these 2 links, this website and this website. Try to play with the numbers, like increase the devices, decrease subnets, increase this, increase the number of bits. Let's the best scenario would be that we give 14 number of bits. Oh my God, I have 32,000 devices still. Not possible, right? So play around with this, and with 15 minutes, once we return, we'll revise this once again. Okay. Let me start recording. Okay, so pretty much we have covered the subnetting. Okay, how subnetting is done, and how do you decide? Okay, yeah, how subnetting is done. How do you determine the network size? What is essentially possible and what is essentially not possible? It is not possible that you can build a network with thousands and thousands of devices and you can have tens or 20s of such networks. That's not possible. Okay, so so thing is that it is way different, right, than thinking like you can have any number of networks and anything that you want. So with that, I think pretty much we have covered subnetting. I would like to see if anyone has any questions on these diagrams, these poor diagrams which I drew. I hope some of this was at least clear. And if you learned how to use these tools, because, you know, and then you can do this calculation. It's not like that you cannot calculate. When we were doing this calculation, right, we know that how it is, right? If I want to have 1000 devices, because I know that, you know, at the end, essentially, 22, only 10 devices are, only 10, 8 and 2. Only 10 bits are left. I can do the calculation myself, but, you know, you have to literally think in binary, make some calculation, draw the diagrams, and you need to really understand the internal working, which we just talked, in fact. So you can do that as well. But these tools are generally very helpful because it can quickly help you calculate number of devices, number of subnets, number of network, many of the things that you want. Okay. So for this reason, this is a very good tool, and this is also very good. Both of them complement each other because, you know, the benefit of this tool is it will help you to split a subnet into further subnets. So let's say you want to have this network subnet, you can divide this one further, right? You can divide this one further without dividing the other ones. Okay, so that is possible. Generally, you don't need. Okay, but this tool will help you even do that. Yeah. So, and this gives you the subnet address very beautifully. Any questions? Any doubts in understanding? I saw that Tom is using binary after a long time. Yeah, binary is very useful, very helpful. And I'm not sure, but if you learn some computer architecture things, you can actually code in binary, because at the end everything runs in binary, right? So when I was learning, I learned assembly language programming. So you actually write the hexel code. So there are many notations. One is binary, another is octal with base 8, another one is decimal, for which the normal public uses, and another one is the hexel, which uses base 16. So that uses 0 to um, uh, 9, I think. Yeah, 9, 0 to 9, and then you have A, B, C, D, E, F, something like that it uses. So you write the code in A, X, B, Y, something, 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 and runs the code. Yeah, that has been like a long time. But at the end, everything that we do is internally binary, right? Everything that we are talking is a binary, right? It's just like it's zeros and ones. When I see George taking sip, it's just like zeros and ones are varying. It's just changing the patterns. So the computer is beautiful. It's interesting, right? So yeah, Phil.
I was going to mention I was at an event earlier this week, and they asked me to hop on and code, and they said, "How's your assembly code?" And I said, "Not that good, but I'm willing to try." And so I think we were playing the Turing Complete game on Steam. They've got like some neat things that you can. I think it's only like $5 or something like that, but at the hack night, we've been building just random stuff in binary, so making, I guess, like adders and splitters and stuff that I don't really fully understand. But we made a Space Invaders game. That's it.
Oh, nice. Did you end up like creating those adders and all, the gates?
They built a full computer. Yeah, they built from from a gateway to and then adding all the functional components and
Sure.
yeah, it's taken. They've been working on it for like 3 months now.
Yeah. So so this is, I think, how the gates look like. This is like the gates. So internally, this is how it functions at the end, the computers. Internally, these are the components which are there. These are like nano scale nowadays, 10 to the power 9 minus 9. In that size, they make these gates and chips. I used to do a lot of this. I had to become pro at one point of time, by the way. But yeah, okay. And all right. So yeah, Turing. Yeah. Okay, I need to see this. Steam Power. What is this? Turing Complete. Oh, I think I've heard about this, but not really. Oh, okay. This is cool. Yeah, this is what I was talking about. Yeah, beautiful stuff. Yeah. We have started learning importing libraries, but we don't know the internal things. All right. So if there is no question, then we will leave you with this lesson on subnetting. Okay. The next lesson that we have is going to be on building VPC and um, during building VPCs and actually deploying a complete WordPress stack on your own VPC. Okay. So idea here is that you will have your own network. Okay. So AWS VPC with public and private subnet. So essentially, this is how this should look like. Okay. So let's not talk about that. Let's just have a simple one. Okay. So this is how your application will elastic. Okay. Yeah, something like that. Yeah, something like this. Okay. So this is the assignment that you have. Okay. And I'm okay to do this in front of you if you want, but otherwise, the way I would like you to try first is you have to build a complete custom VPC network, and then you have to deploy your WordPress on the public subnet. Then you have to deploy your database in another EC2 server in the private subnet. Okay. And then you have to connect each other. Okay. And after that, since the private subnet cannot go to internet, you have to attach internet gateway. Okay. How many of you know using internet gateway in the VPC? What is internet gateway? Sorry, internet gateway and NAT gateway. Can someone tell me what is internet gateway and what is NAT gateway?
I thought the internet gateway was just allowing traffic to the internet or from the internet publicly.
Mhm.
And I thought the NAT gateway was when you only allowed certain like IP addresses or certain traffic to and from that gateway, but I could be wrong.
No, I think you're pretty right. Yeah, pretty close. So in NAT gateways, NAT is like network address translator. Okay. So this will help you to connect to internet even from the private subnet. Okay. Why do we need NAT gateway, by the way? Why do we need NAT?
Is it a way to allow private subnets to still have internet access?
Okay. But yeah, but what is the benefit? Why do we even do that?
Added layer of security so no one can see what those IPs are from the outside.
Mm-hmm. Okay. Okay. Yeah, that's. Mm-hmm. Okay. And in many of the companies, what happens is that NAT gateways are even used. Okay. Even if the need is to allow public access. Okay. So one of the very important thing that NAT gateway solves is NAT gateway, NAT instance solve is the address translation. So if you, when you make the request to go to public, okay, it takes the request, makes a record, okay, and sends the request to public. Do you know how NAT gateways internally work? This is how they work. Okay. So NAT gateway function. Okay, if you write, we should have something like this. Okay. So what happens is the request that you make, okay, it takes the request in its own record. It keeps a record that this request has come from this particular private IP address. It sends the request to internet, gets the response, and gives the same response back to the private IP address which made the request. So this is how it works. So it helps a lot in security, first of all. Second thing is it saves a lot of public addresses. Security is definitely one aspect. Okay. Another aspect is there is lack of IP addresses in the world. Okay, so there are only few millions or something, that many IP addresses are available in the world. So let's say that you had, let's say, 1,000 servers, right? If let's say all 1,000 servers, they want to go to internet, it will become very problematic, right? We cannot have those many IP addresses. We don't have that many IP addresses. So what we do is, all the private subnets will have private IP address, will have just one NAT. It will take the request, send it to the public, get the response, give it back. So it saves the numbers of public IP addresses, which is very scarce. Okay, so that is a very important aspect as well. What is the fix for it? We have gotten, so it was IPv6. We have gotten now, what is the latest one? It is called IPv4 versus IPv6. So let me show you some difference. You can go and read about this more. So this is the difference between IPv4 and IPv6. So what happens is that in IPv4, what we use right now, there can be only certain number of IP addresses. Okay. In IPv6, you can have large number of IP addresses. Okay. So that is one thing. So see, IPv4 can generate only 4 to 9 into 10 to the power 9 IP addresses. This one can generate 3.4 into 10 to the power 38 IP addresses. So now industry is probably moving to IPv6. People are saying let's use IPv6, but still it's like a long way. Still, I haven't seen any good progress. So you can go and read about this. The difference between IPv4. It can come a very easy IP question in any interviews. IPv6 and IPv4. IPv6 is so large. See, yeah. In IPv4, you can generate only 4 billion unique IP addresses. Only 4 billion. Right. But how is the world working? We have more than 7 billion population already. Everyone is using more than 5-10 devices, like 2-3 phones, few laptops, servers, because we are using NAT addresses, NAT gateways, and preserving the IP addresses. This one can have 340 undecillion IP addresses. That is like so much. People say that you can give every atom one IP address. It is that many IP address. So it's pretty large. So you can go and read more about this. So that completes. Okay, we don't want IPv6. You go and create VPC like this. You can click on create VPC. Once you have created the VPC, then based on this calculation, how many devices you want, let's say I want this, okay, you can have your IP address start, and you can go to subnets, and you can create the subnet based on your need. So this was this. You can go ahead and you can give the the name. CIDR you can give here. Okay, give 22. You can give 20. You can give 24. But you see, as you keep changing, number of IP addresses will keep changing. Sounds good, everyone? All right. So this was the first part of learning subnetting and IP addressing. The next part of today's lesson is on building a custom network and building a VPC. And on the VPC, deploying WordPress. Okay. So there is already a good tutorial given here, everyone. That is given as appendix. Okay. How to deploy this. So if you want, you can take this help. I would suggest you give it a try yourself first. and then we can talk and visit this again. So this is how the stack will look like. Okay, you will launch a custom VPC. We'll have router, routing table, internet gateways. You will deploy the LAMP stack. Route 53 and all can be left. Don't worry about it because this is costly service. You can just create the whole stack and launch the LAMP stack. So this is the assignment. I would like everyone to do this assignment today because this will clear a lot of doubts from your mind. Okay. So if ever, I would like to see if anyone is able to do this now in the afternoon. Otherwise, we can have a demo if someone is able to do it. Okay. This is what we'll have in afternoon. In afternoon, if let's say we are able to do, I will not take this new lessons. I will talk about probably 1 or 2 new service if time permits. Okay. All right. So that's long session already in the morning. We talked a lot about IP addressing, subnetting. Please practice with that. And yeah. Yeah, I think, we can delete some IP VPCs, subnets, and gateways, which we don't use so that it can save a limit. Second thing is it can save the cost. And yeah, I know those who are participating in hackathons or something, it's okay. You can, schedule your time. Cassandra, I know that you have some pre-committed leave, so you can please go ahead.
Thank you.
Yeah. So how many of you are going to participate in the hackathon? Let me know if you're going off. Phil is participating, Nika is participating, Joe's. All right. Okay. So we have 4 people already participating. No worries. If you want, you can work on that if you want. Meanwhile, I'm here if you need any help. All right. In afternoon.
I'm going to try to get the assignment done.
Perfect.
At least it started, if nothing else. I feel like I need to.
I think I would like this VPC assignment done by everyone because this will clear a lot of your doubts. Okay. Yeah. All right. So let me